So let me write a code for that one, and then maybe the others you can just follow it. So first of all, we check if k is less than equal to 0 or greater than length. Length method we have already found. So length of head plus 1. If that is the case, I don't do anything. You simply return the original head. Makes sense? This boundary case is clear, guys?
Yes.
Why I have done +1? I've done +1 because suppose in this the length is 1, 2, 3, 4, right? So only if the k value is 5, I can go and add it here. I can add it here, right? But if k value is 6, I don't have any 6th position, right? So I only have to change that the k value should be greater than equal to 1, and it should be less than equal to the length of the array list +1. Apart from that, if anything else is there, I'll just return head. Now let's first create the new node that I have to add. So list node, new node is equal to new list node, and make it as like that. And then I check if k is equal to 1. If k is equal to 1, it has to be added at start. If k is equal to 1, what I do just do is that new node dot set next becomes equals to head. So what I have done is that with this, suppose k was this, so I would have just add, for example, if k is equal to 1 and data is equals to 4 in the start I have to, so basically I would have converted this linked list.
So Vishwa,
yeah,
do we have to check if the new node is actually a null?
No, so basically I have passing data. Data is a value, right? It's an integer. It cannot be null. It can be integer. It can be 0. It can be -1, something like that. This data cannot be null, right? It is an integer value.
Wrapper type of integer can be null.
Achha, you are saying that if it is like this, you are saying?
Yeah.
Yeah, if it is passed like this, then we need to check it that if it is a null or not.
I'm asking, can a linked list hold a null or not?
So it all depends on how you have defined this list node. Okay. So right now in my list node, I have used int as a type. You could have used integer also. And in the case if it is integer, then it can definitely hold the null value inside it, right? So it all depends on how you have internally defined your data structure. The way I defined is internally. So right now my linked list will only contain the integers, right? It cannot hold any string data. But suppose if I have to create a linked list which has to store the string data, right? In that case, I have to modify this of the type string. Like this, we'll have to do it, right? In Java, normally, if we have to actually write like this for a different kind of data types, we use Java generics, in which you write the same class, but it applies for all the different types, right? It may apply for the integer, it may apply for the string, or for any kind of custom objects. So therefore, you use the Java generics. But I don't want to go in detail into the language specific things. So that is why I'm just talking about, because mostly in the data structure thing, we'll mostly be handling with the numbers. So I've just defined it for the int as of now. If we need to do for the string, you just have to go and change the data type here as a string, and it will start working for you. Make sense?
Yeah.
Right. So if k is equal to 1, it means that it has to be added at the start. So in that case, I do this. Okay. And once I do this, what is the 1, 2, 3, 4 has now been converted into the 4. 1, 2, 3, null. Right. It has been converted now. And the new head is 4 now. So what I do is that I return new.
Head is not automatically get pointed to the first node. We have to explicitly point it, right?
No. So what I've done is that initially it was 1, 2, 3. I created this 4 node, and 4 next has I pointed to the head, right? So whatever that is at the first position now is my new head. So I'm just returning this 4, which is my new head as of now.
If I would fetch the head, so I would get 4 or 1.
Okay, I got your point. So you are saying that head will still point to this, whereas the actual head is this. Okay. So basically, when you return this is returning head. But if you want to explicitly do that, head now points to the new node, and you return head like. Now this makes sense to you?
Yeah.
So now the head points to the new node and then returns head. Okay. So this is what we do. Okay, I remove a return statement here. I just do this, head equals to this. Else, if this is not the case, if this is not the case, now I have to do the same logic which Vivek applied, and I have to find a count. So I do a int count equals to 0, and list node temp equals to head. So basically what I need to do, suppose if I have to insert at the third position, so I'll go till the second position, right? And then do all this manipulation. So we'll try to do it here. So while count is less than k. So if count is less than, actually k minus 1, not k. Or I can put count is equal to 1 and this count is less than k. And what I do is temp equals to, and I do count plus plus. Okay. Once I come out of this while loop, right, temp will be the k minus 1th node, right? When I come out of this, while loop, the temp will now at the k minus 1th node. Okay. So what I know do is that I find the next node to it. So list node next equals to temp dot get next, and the new node that I have created. So as you can see, so I'm here right now, and I have found next node. So this is my next node that I created, and this is 7 is the new node that I created. So basically, what I do 7 dot next should be this one. So this I'll do in the code. So my next node is new node is this one which I already created. So new node dot set next should be this next. Okay, so once I do this, basically I have I have implemented this part I have done now. Okay, now I'm left with I have to remove this and I have to do this one, right? So what I do now is that I do temp dot set next, temp dot set next, I do new node. So once I write this command, it means that now I have deleted this and I have added this thing is done. So now things happen, right? And so after this statement is done, my linked list new element is added, and in the final I have returned the head again, right? So this is the code that we arrived to insert a node at the kth position in a linked list. Make sense? Is it clear, everybody?
Yeah, so I have one question. What if we have written line number 88 earlier to 87?
If we do temp.setness earlier to 87, so here let's try to see that. Okay, so suppose suppose it was okay, it was 3 and it was 4, and this was my new node. Suppose okay, this is my new node. Okay, so suppose you are saying that instead of doing this, I do this first. I do this first instead. So initially it was this. So if I do that line first, I have done this, and I have removed this, right? So if I did that step, this part now is completely lost. There's no way that I can get this point, right? And if I have to, then I have right. I have lost this point, lost this connection. So in that case, I'll not be able to connect these 2 points, which is important. I'll not be able to do this if we do that step. If you see the code, if I do line number 88, you are trying to say the new node. If I put it here before like this. So when I do temp.set next is equal to new node, it has done this. Okay, so basically it has removed this one, and this is the part which get executed, right? And then you do next node is equal to temp.get next. Now temp is this. Okay, temp is this, and this next should be temp.next. So basically it will go and connect to itself.
Right.
This dot next temp dot, so it will get connected to itself. And new node dot set next is equal to next. So basically this will result in like this. So this part, so there will be a this part will get separated. So our linked list will become like this, and it's actually not insertion. We have divided the linked list into the two parts. So this is what will happen. Make sense? So basically, I don't need to do this. I'll write this line after this line. Make sense? Is it clear?
Yeah.
Cool. So this is how we do insertion. So this is the CRUD operation C part, right? Similarly, I have to do right public list node update, and in this I have to pass list node head and data and k, right? So I want you guys to implement this method, taking into consideration all the boundary conditions. So what is the question? The question is that you have given a head, you have been given a data, and you have to update the this data at the kth node. So initially, suppose it was 4, you have to replace it by 5, for example, right? So do it as an assignment. Okay. Another thing that you need to do is that public list node delete, and again list node head and k. So you have to go and delete the kth node. Again, you need to do it as an assignment. So you have to update, you have to delete, and you have to create. I have already shown you how do we do it, right? So everyone clear on this assignment? You are clear on what you have to do? Everybody?
No, fine.